working on 3J. So 3J is about modeling a quadratic. So really about understanding it on a deeper level to be able to apply. So let's go through this here. A piece of rope 80 centimeters in length is used to form a rectangle. So if, now, if X centimeters is the width of the rectangle, so I'm going to highlight that. X centimeters is the width. 8 centimeters squared is the area enclosed by the rectangle shape. Write down a formula that connects A and X. So the first thing that I'm to do is I like to draw a picture. So width is X. But we don't know what the length is. So at the moment, I'm just going to say the length is. So first thing we are going to do is we are going to try and simplify this as best as possible. So the first thing that I will be looking at doing is looking at one, what is the 80 for? 80 is telling us the perimeter. So that means I know 2 of my length plus 2 of my x is going to be 80. Because I've got 2 on both of them, the first thing I'm just going to do is divide everything by 2 to get rid of it. So that will give me L plus X is equal to 40. The next part is I would like to work out what L is in relation to X. So L is going to be equal to 40 take away X. Now, if I go back to my picture, I'll erase those L's and I'm just going to put in 40 minus X and 40 minus X. The next part is coming up with a formula with area. So if we're talking about area, how do we work out the area of a rectangle? We do that by doing length times width. So area is equal to X times 40 minus X. That's the formula, and that's in relation to A and X. Then it says sketch the graph of A and X with suitable X values. So straight away, if on the right-hand side, I will just draw this. This is already perfect because it tells me straight away the two values. So the first thing is how can I look at the x-intercepts? That means A is 0. To get A is 0, I've got the x. If this is 0, the whole thing is 0. Or I can look at it in terms of is 40 minus x 0, the whole thing is 0. So that helps me out a bit because that means I know my intercepts are going to be right here on the origin when x is 0, the whole thing is 0, and also when it's at 40. Next part, work out the turning point straight away because I've got 2 points. I know the turning point will be halfway point, which will be when x is 20. It's always going to be the halfway when we've got 2 points. Another way of thinking about that is looking at using the axes of symmetry. And remember, the axes of symmetry is x is equal to negative b over 2a, and that will give me the same amount. And I'll need to get that to standard form. Now I know it's 20. All I need to do to find the turning point is substitute that amount in as 20. So over here, I'm just going to go a is equal to 20 in brackets, 40 take away 20. So 40 take away 20 is 20, and 20 times 20 gives me area of 400. So, oops, let's go back. That means When area is 400, my x is going to be 20. And that gives me my graph I can use. So this also answers part C. Use your graph to determine the maximum area that can be formed. The maximum area is 400 centimeters squared. And let's look at the next question. A person standing on the edge of a 50-meter high cliff throws a ball horizontally. The height h in meters of the ball after it has traveled x meters horizontally. The height is given by the rule h is equal to 50 plus 2x take away 1 over 40x squared, whereas x is equal to or greater than 0. Sketch the graph for the values of x ranging from 0 to 50. Okay, so I'm just over here, I'm just going to draw a graph. Oops. So I know straight away that my C value here, just in a different area, is going to be my y. So I'm just going to label that as 50. The next part that I'm going to look at is wanting to know my x-intercepts. Because straight away here it's negative, so I know it's going to go up. And I want to know my turning point as well. So because of the numbers that we are using, we've got 1 over 40, I'm just going to make it easier on myself, and I'm going to use the quadratic formula. So x is equal to negative b plus or minus square root b squared minus 4ac over 2a. So the first thing I'm going to do is substitute all the values into my equation. So that will give me b is 2. So I've got negative 2 plus or minus. b again is 2, so 2 squared is 4. Then it's got negative 4 times a, which is 1 over 40. And it is a negative. I'm making sure I'm putting this straight onto the calculator. And then I am timesing by c, which is 50. And that equals positive 5 because the negative and the negative becomes a positive. So then over 2a, a again is 1 over 40. So that means it will be 2 over 40, which will be a negative. So negative 0.0. I'm just going to move down and do the rest on the left-hand side now. We can simplify this now down to 4 plus 5 is square root of 9, which will give me 3. So that gives me x is equal to negative 2 plus or minus 3 over negative 0.05. The next thing is just putting those two amounts into a calculator. The first answer I've got with the plus is x is equal to negative 20, or the second one I have is positive. Now, that means here that I can put in 100 here. I'm only looking at 52 zeros. Just be mindful of that. And I'm not looking at this part, but I know this goes up. So straight away, I know between negative 20 and 100, that means the halfway point must be 40. So 40 is going to be where my turning point is. So to finish this off, I just need to substitute x as 40 into my equation. You can do that on your calculator, and if you do that, you're going to get 90. So that means at 90, that is going to be the maximum. And since we're only wanting to graph until 50, it's going to be this point right here. I've just done all the other calculations. So there, this answers multiple questions. What is the maximum height reached by the ball? It reaches 90 meters. And at what height was the ball thrown? That is always going to be the y-intercept, and the y-intercept is 50